In this video, we will be solving triangles using the law of sines, but specifically we will be focusing on the ambiguous case. That's the situation where we have side angle information given, two sides and the non-included angle. Because when we're given side angle, we don't know if we will have a triangle at all. It's possible that no triangle could be formed. And if we can make a triangle, it's possible that there could be one triangle, but it's also possible that there could be two triangles. So that is quite ambiguous indeed. So when we look at problem number 4, right away I see that we have two sides and an angle. So I'm thinking, okay, this could be the ambiguous case, so I definitely should prepare for that. So the way you handle side angle is you draw a horizontal segment, bottom of your triangle. On the left hand side, go ahead and draw yourself an angle. Okay, go ahead and put your one angle that you're given inside that angle, so that this will be angle A. Alright, think of this as a hinge, and I'm going to draw a dotted line from there. This is going to be what I call the swing side, because in my mind I'm picturing this is like a rope that can swing from side to side. We don't know if it'll reach, we don't know if it'll form two triangles. That's why I make it dotted. Anyway, if this is angle A, the rope over here, the swing side, is side A, which we know to be 5. Now, we're given another side, 6. Go ahead and let that be the rigid side over here to the left. So I'm going to put my 6 right here. Now that's side B, which makes this angle B, which makes this angle C. Now, when you have a side angle like this, your first job is to decide, can you make a triangle out of this at all? And the way you decide if you can make a triangle at all is you calculate the height of the triangle. Okay, so I'm going to call this H for height. The way I calculate the height is I do the sine of my angle. So the sine of 63 is going to equal opposite over hypotenuse. Alright, so that's H over 6. Multiplying both sides by 6, that's going to give me 6 sine 63 is equal to that height. So I'm going to punch that in my calculator real quick like. Okay, 6 sine 63. And that is giving me 5.346 as my height. Okay, 5 point. Alright, I'm going to round it to 5.3. Alright, so I need to look at this information and ask myself, can I form a triangle at all? And I can see that the answer is going to be no. It was pretty close, but look, the swing side here is like a rope that has to reach from one side to the other. But the height of the triangle is 5.3. It's a little bit more than 5. So that means, best case scenario, if I were to stretch this rope straight down, it just wouldn't quite reach. It's only a length of 5. Okay, I should erase part of this to show that this is only a length of 5. The height of the triangle is 5.3. So there's no way that it's going to reach all the way to the ground. It'll come close, but it'll be 0.3 away. There'll be a little gap there at the bottom. And so there's no way that you can form a triangle out of this, not even a right triangle. So that makes this problem easy in the sense that I have to stop right now and say no solution. Alright, because no triangle can be formed. Alright, let's move on to the next one. Okay, next one's kind of a word problem, so I better zoom out. A ski lift rises at a 28-degree angle during the first 20 feet up a mountain to achieve a height of of 25 feet, which is the height maintained during the remainder of the ride up the mountain. Determine the length of cable needed for this initial rise. Now that would be a confusing wording of a problem if they had not given us this nifty little picture. Now, you may notice in this picture that we are given two sides and an angle. So we are given a side-side angle situation. However, we don't really need to worry about it the way we normally would in terms of will it make a triangle and all of that, because they gave us the picture and they're just asking us to find a missing side. So we already know that it is going to make a triangle, and we don't have to worry about whether or not it makes two triangles or anything like that, because this is the triangle they want us to solve. So this is really not special. We can just go ahead and solve the triangle. Okay, so let's go ahead and set up our law of sines. So I'm looking at the information I have. I see I've got this angle and I've got the opposite side. So I can set up my law of sines by doing sine of 28. Okay, sine of the angle over the opposite side. Okay, now what other piece of information do I have? The other information I have is I have this side right here. Okay, this side is length 20. So I can set this up to find the opposite angle, which I'm going to call theta. Okay, so I can say sine theta. Alright, so I can use this equation to find angle theta. So let's go ahead and do that. So to find the sine of theta, I will multiply both sides by 20. That way these 20s are going to cancel each other out, and that will leave me with sine theta. But what I actually want is the measure of angle theta. So if I want the actual angle out of this, I'm going to have to do the inverse sine of everything. So the inverse sine of 20 sine 28 over 25, that will give me the actual angle theta that I need. So I'm just going to put all that in my calculator right now. That came out to be 22.0, I started to say 0.5, but then it's like 999, so I'm going to say 22.060. Alright, so that is angle theta. But suddenly I have two angles in the triangle, so that means I should be able to easily find the third angle by subtracting from 180. So that's what I'm going to do. I'm going to subtract these two angles from 180, and that will give me the third angle. That gave me 129.94. 129.94. Okay, now I can use that in order to find the opposite side. Basically, I can do the law of sines again. But this time, because I'm looking for a side, I'm going to put the sides in the top. Alright, in other words, instead of doing sine 28 over 25, I'm going to start off with 25 over sine 28. Alright, again, I'm doing this because I'm looking for a side, so I put the sides in the top. So that will equal x over the sine of the angle, so x over sine 129.940. So to get x by itself, I just need to multiply both sides by sine 129.940. That way these will cancel each other out, and that will just leave me with x, which is the very thing I was trying to find the entire time. So I'm just going to put all this in my calculator, and that should give me the answer. And I am getting 40.829. And we have units this time, so I can go ahead and say feet. Alright, and that is the length of x that we were looking for. So that is it for this word problem number 5. Alright, let's press forward. And number 6 is back to a regular old problem. Okay, it looks like they're giving us a hint that there will be 2 triangles. I'm not sure why they're giving away all this information instead of letting us figure it out for ourselves. Don't really like that. I like to find things out for myself. But anyway, we are given 2 sides and an angle. Right away, that lets me know that I might be dealing with the side-side angle scenario, the ambiguous case. So the way you deal with that is you draw yourself a horizontal segment like this. On the left hand side, make yourself an angle like that. Alright, think of this as a hinge, and imagine stretching a rope from that hinge. Okay, this will be thought of as the swing side, like a swinging rope. Now take your one angle and put it in the angle that you've just formed. So in this case, this is angle A. That makes this side A, which we're told is 5. And go ahead and let your other side, your rigid side, be the other side. So this will be 9. This is side B, that makes this angle B, which means this must be angle C. Now, before I go any further, I need to, the way you determine whether or not you can make a triangle out of this at all is by calculating the height of the triangle. And we can do that by taking the sine of 26. Because sine is opposite over hypotenuse, so that'll be h over 9. Multiplying by 9 on both sides, that will give us 9 sine 26 is equal to the height. Put that in your calculator real quick. So 9 sine 26, that is giving me 3.945. Okay, so approximately 3.9 is the height. So looking at the swing side as a rope, will the rope reach the other side? And yes, it will. The rope is length 5. The height is only 3.9, or about 4. So the rope is long enough to reach, so we will have at least one triangle. So then the question becomes, is it possible that we will have 2 triangles? Well, the way you would have 2 triangles is if you swung this rope inward, and if you could also fit the rope right here, then that would form a second triangle. So the question is, will this rope fit inside the triangle like this? And in this case it will, because the rigid side is length 9 and the rope is only length 5. So the rope will fit inside of here, and at some point it's going to touch the ground at just the right angle, and we'll have to calculate all of that. But because the rope is less than the length of the rigid side, it will fit on the outside and it will also fit on the inside. So we will have 2 triangles. Now, rather than trying to fit all my calculations in one picture, what I like to do is, you know what, let me put that back for a second. I like to draw a separate picture for the inner triangle. So that's what I'm going to do right now. So see the little skinny triangle that's over here? Alright, formed by this pink rope position. I'm going to redraw that over here. So imagine that this is that segment AC. Okay, so this is going to go over a little ways. Alright, about like that. And then you've got your swing side that came in like this. Okay, so I'm trying to make it look as similar as I can. So this is A, and this was that 26 that we were given, and this is 9, and we already know that this is 5, and so angle B for this triangle would be right here, and this will be angle C up here. Now, because we have two triangles, we can't just call it A, B, and C. So I'm going to call this A2 and B2 and C2. And I'm going to call this A1 and B1 and C1. So that's how we will tell them apart. So we have two triangles to solve for this time around. Let's start with the blue triangle. Okay, A1, B1, C1. So let's go ahead and set up our solution box. So I'm going to need to find the measure of angle B1 and the measure of angle C1 and side C1. Alright, those are the three values I will need to solve the blue triangle. So let's go ahead and solve that like we normally would. So the first thing I will go after is angle B. So since I'm looking for angles, I'm going to put angles in the numerator. So I will say the sine of 26 over 5 is going to equal, and I'm going to say the sine of angle B1 over 9. Alright, so to get sine of B1 by itself, I'm going to multiply both sides of this equation by 9. That way these 9's will cancel each other out, and that will leave me with sine of B1 by itself. But I don't really want the sine of B1, I want the angle itself. So if I want the angle out of this, I need to do the inverse sine. So I'm going to do the inverse sine of all of this. Alright, whoops. Alright, I'm going to do the inverse sine of all of this, and that should give me the measure of angle B. So just put all this in your calculator. That is 52.099 degrees. Okay, so that is 52.099. Now we could easily calculate the measure of angle C1 by subtracting these two from 180. So that's what I'm going to do. So I'm getting 101.901. Okay, that just leaves side C, which again I can find using the law of sines. Since I am looking for a side this time, I am going to put sides in the top. So this time I'm going to say 5 over sine 26 is equal to C1 over the sine of 101.901. So to get side C by itself, I am going to have to multiply by the sine of 101.901 on both sides. That way these will cancel out, leaving side C1 all by itself. So I'm just going to put all this in my calculator, and that will give me C1. And that gave me 11.161. Okay, so that is it for the blue triangle. We have solved the blue triangle. Alright, now it is time to solve the pink triangle. Well, the red triangle. My students would yell at me because they don't consider this to be pink. They consider it to be red. So I will concede and call it red. But to me it's pink. Anyway, we need the same pieces of information. We're going to need to find the measure of angle B2, and we need the measure of angle C2, and we need the length of side C2. So we will need these three pieces of information in order to solve the triangle. Now, the one thing that's got to be different this time is the way I find the measure of angle B2. I can't use the law of sines again. The law of sines relied on me doing the inverse sine. And the inverse sine gave me this acute angle, 52.099. If I were to do the same thing again, I would get that same acute angle again. And clearly this time I want an obtuse angle. But guess what? Inverse sine will never give you an obtuse angle. So, well, luckily I can get the obtuse angle B2 using the acute angle B1. These two angles will always be supplementary. Alright, whenever the swing side forms two triangles, you can subtract from 180 to find the other angle. So I can get angle B2 simply by doing 180 minus B1. And this will work every single time. Alright? Okay. On a previous video I've explained why. I'm not going to go into it this time. Okay, so I'm just going to subtract from 180. So B2 should be 180 minus 52.099. I'm getting 127.901. Alright, and I barely have enough space for that. I'm running out of paper. 127.901. Okay, so that's my obtuse angle here. So I can find angle C2 by subtracting these two from 180. So that's what I'm going to do. I'm getting 26.099. Okay, that just leaves side C2, which is right here. Okay, so we're going to use the law of sines one more time. And again, since I'm looking for a side, I'm going to put sides in the top. So I am going to go ahead and do this. And I'm going to say 5 over sine 26 is equal to C2 over the sine of 26.099. Alright, so in order to get C2 by itself, I need to multiply both sides by the sine of 26.099 on both sides. That way these will cancel each other out, and that should give me C2. So I'm going to put all of this in my calculator to find side C2. I'm getting 5.018. And that's it. We have solved both triangles. Okay, so we found the red triangle and we found the blue triangle. So for this one, we had two separate solutions.